Principal Sheep. Welcome back to our classroom. Today, I will be teaching you about enzymes. Enzymes are catalysts, a substance that increases the rate of a chemical reaction without being changed or used up from the reaction. They are all proteins, which are made up of chains of amino acids, which are folded into unique shapes that it requires to do their job. This is called the lock and key model. I'll give you a few questions on what they are. What are catalysts and what are they? You must say both. These are examples of answers that you could get. A substance that increases the speed that useful metabolic reactions occur without being used up or changed. They're proteins / they're catalysts. You must say both of them. This is the parts of an enzyme. The middle diagram shows the lock and key model from before. As you can see, the enzyme is the pink thing and the substrate is the purple thing. The purple thing goes inside the active site to be separated, and the two separated things are called the product. I'll give you a few questions on the parts of an enzyme. What is the part that a thing joins or splits apart called? What is the part that goes into the answer to question 1 called? The active site and the substrate. Now I'll tell you why they're very important and why we need them. Usually we would need a very high temperature to speed up metabolic reactions, but even if we did have a high temperature, even the bad ones would speed up, which isn't good at all. However, with enzymes, we do not need high temperatures and they only speed up the useful chemical reactions while the bad ones are slower. Why are they so useful, and why would having no enzymes be bad? Because they don't speed up any of the bad reactions, only the helpful ones. Because then, we would need a high temperature constantly, which would not only speed up the good metabolic reactions, but also the bad ones, which would be terrible news. How temperature affects them. Similarly to any reaction, initially a higher temperature increases the speed because the enzyme and substrate will have more energy, making it more likely they will collide and create a reaction. Every enzyme has an optimum temperature, the best temperature for it. However, if it gets too hot, the bonds holding the enzyme together will break, which changes the shape of the active site, making the substrates unable to fit. This is called being denatured, and this is killing the enzymes. What happens to an enzyme when it gets too hot? What's it called? Why is it initially good for the enzyme to be warm? The answers are, the bonds holding it together break, and this changes the active site's shape. It's called being denatured. The substrate and enzyme gain more energy and move around more, so they have a higher chance of colliding. All enzymes have an optimum pH, just like they have an optimum temperature. Often a neutral pH 7, but it's not always 7. If the pH is either too low or too high for the enzyme, it will start interfering with the bonds on the enzyme, which changes the shape of the active site, just like temperatures, making the substrates unable to fit. It's also called being denatured. What is often the optimum pH? What happens if the pH is too high or too low? The optimum pH is usually a neutral pH 7. pH starts to interfere with the bonds of the enzymes, denaturing it. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.